So ANOVA is used when we have 3 or more populations. We have 3 or more groups. So when we did a t-test, we either had one sample and we're comparing it to a population, or we had 2 samples and we're comparing them together. But now we have 3 or more populations or samples, and we want to compare the averages of those groups. So ANOVA answers this question: are there any differences between the group averages? One caveat of the ANOVA is that it doesn't tell you where the differences are. So say we have 3 groups, 1, 2, and 3. It will tell you if there are differences between the groups, but it won't tell you where the difference is. So we don't know if, for example, there's a difference between 1 and 2, 1 and 3, or 2 and 3. But we know that there is a difference, so there's one of these will be significantly different from each other. So you would need to do post hoc, what are called post hoc confidence intervals after you do the ANOVA, or post hoc t-test. So ANOVA is an overall test. It's not a kind of a specific test like a t-test is. So just keep that in mind. But you want to do the ANOVA first before you do the confidence intervals, just to keep the type 1 error rate down. So what does it mean by between subjects? So a between subjects means that there's no pairing, and this is similar to an independent 2-sample t-test but with more samples. So just remember that between subjects means there's no pairing. Within subjects, which is what we're going to go over next, is a repeated designs study, and where we have the same person taking the same test over and over. So just remember this is for a between subjects when there's no pairing. So you might ask, what does ANOVA mean? And it stands for analysis of variance. So the AN here comes from the analysis part, the O comes from of, and the VA comes from variance. The key word is variance. So when we did a t-test, the independent t-test, this was our formula. So we had x bar 1 minus x bar 2 over s over the square root of n. And basically we're not using variance here, right? We're using the standard deviation. And that worked, and because the top here is also in a similar form, kind of like standard deviation. Nothing is squared, right? But when we do variance, it gets squared. And the reason that's important is because we have 3 groups now. So let's take, for example, say we're doing a t-test, and here's our first distribution and its mean, and say it's at negative 30 for group 1, and then for group 2 say it's at 10. So we could subtract this, right? And we have a difference here of negative 40. So that means from 10 to negative 30, that's a span of 40, right? And that was okay when we had a t-test. But now let's add another group, group 3. So now we're going to have to do ANOVA because we have 3 groups. But say that mean was at 40. or negative 40. So if we subtract off negative 40 here, then we're going to get 0. So we're going to get 0 here. Now, that means that there's no difference between any of these. But clearly we can see that there is a difference, right? Negative 40, negative 30, and 10 are all different means. But if we just subtract them all, then we could get a value of 0. And before, when we just had two groups, 1 and 2, the negative 40 was a range. So it was a range between those two means. So the range between negative 30 and 10 is negative 40. But now when we have three groups, what does that really mean? And we could also get a value of 0 when we subtract them. So just subtracting and getting a different score like we did up here for a t-test, getting a difference, not a different score, but a difference, doesn't work anymore. We need a new method, and what we're going to do is use variance, because we're going to square the deviations from this grand mean that we'll get. And that allows us to really measure the variability instead of just doing differences and using a range.